Since the dawn of humanity, we have been migrating from one place to another. To discover, look for resources, find a safe place to settle, or even colonize lands. Survival, curiosity, and domination are all instincts that drove us to seek beyond the horizon. After we have reached our Earth boundaries, the space age started when nations started to compete beyond Earth, looking forward to dominating outer space, colonizing the Moon, Mars, and even beyond. But colonization comes in phases. First we go explore but without staying, like in the Apollo mission in 1969. Phase 2 is creating small settlements, but we are still dependent on our home country. In the final phase, we build colonies, control the resources and immigrate to the new land, and this could be the new phase to colonize Mars. Our current challenge is the second phase, and this time the challenge is completely different. The Moon is not a welcoming place for living things, due to the lack of a lunar atmospheric envelope, and the long lunar days, as one day on the Moon is equal to nearly 29 days on Earth. These factors lead to a high difference in temperature on the Moon's surface between lunar day and night. Micrometeorites rain frequently on the Moon. A high amount of exposure to space radiations and cosmic rays. There are also seismic that happen frequently on the Moon. The need to find water for living and generating energy to stay for longer periods. On the Moon, there is a high amount of dust in the lunar environment. The microgravity, as the gravity on the Moon is 1/6 the gravity on Earth. That's why it is important to consider a good shield for the habitat, the period of stay, avoiding joints, and an emergency plan. Also considering the landing location. On the surface of the lunar South Pole, the temperature average is 13 degrees Celsius below zero, and there are some craters where the temperature was detected to reach 250 degrees Celsius below zero, where sunlight strikes its surface at a low angle, and it never reaches its bottom. Water ice is stable at these temperatures, and there is strong evidence that some of these craters contain significant ice deposits. Before coming to the habitat design, some strategies have been set. The first strategy is providing the maximum protection from radiations with minimum weight possible by using polyethylene sheets and fabrics in the interior, since materials with high hydrogen content can reduce effect of radiation more than metals. The second is to provide the maximum possible function within minimum space and dimensions. Also combining functions as much as possible to provide multifunctional spaces and take the maximum advantage of them. These strategies are essential since the habitat will be transferred to the Moon within a limited volume in the payload of SpaceX Starship, which should occupy the service module, the habitat, and the lander. The service module will be used in case of emergency or after the mission end to bring astronauts back to Earth. The habitat is shaped to provide a habitat space of a diameter of 8 meters with a small atrium in the middle, and surrounded by a regolith shield with some subtractions from outside to add the solar panels. Finally, the landing module is used to land the habitat on the Moon after reaching lunar orbit. It's shaped to host 18 steering rockets, 3 fuel tanks, and the airlock, all surrounded by a regolith shield. These 3 components are designed to fit in the Starship payload to provide maximum space and function efficiency. Inspired from the combination between the pumpkin fruit outer shell and Mercury capsule's spacecrafts with its titanium skin, the form of the lunar habitat came to life. When coming to the habitat zoning, the ground level will occupy the airlocks, engines and tanks. The first level will be the individual noisy zone. The second level will be the individual quiet zone, then on the third comes the social noisy zone. And finally come the solar panels and the skylight. Level 1 and 3 are double height levels which are divided into 2 sub-levels. The floor height is 3 meters in normal levels and in double height levels is 5 meters divided into 2 sub-levels 2.5 meter each. The floors are made of high tensile fabric structure to achieve minimum weight possible. On the ground plan, there is the airlock with its vestibule, and the astronauts' space suits. On the first level, the control station, power supply, and water tanks are on the lower level. And on the upper one, 3 labs, life support, and equipment storage. All the heavy equipment is distributed down to ensure a smooth landing with minimum tilting. On the second level, there are 4 sleeping quarters, toilet with shower and laundry. The level is multifunctional by using fabric folding partitions so that it could be used as a micro-social space as well. And on the final level, food storage, galley, the living space, recreation, and exercise are on the lower level and hydroponics are on the higher one. The level is also flexible by combining many social functions together in one space. All the furniture is simple, out of rail and fabric and could be inflated and evacuated to ensure lightweight. There is a lightweight aero trim out of fabric ropes for astronauts to exercise by trying to balance themselves inside. Panoramic display and periscopes similar to submarines through the skylight to allow astronauts to view outdoors without creating windows and being exposed to radiation. The vertical circulation in the habitat is through 2 main axes. The escape chute to be used in case of emergency and main central shaft out of ropes and rail since they are light and flexible for movement between levels. The structural system is formed by hollow I-beams since they are light in weight and the foundations will be provided with seismic springs to protect the habitat from quakes. Then comes the aluminum grid covered with the titanium skin. The regolith will be transferred in two main rods to fill in between the structures. Areas with low regolith thickness are compensated with regolith from inside. Not only functions as protection from radiation, but also regolith could be planted and be an interior vertical garden. Reversible cells have the ability to generate energy from hydrogen and oxygen to give energy and water in an endless process. Water from tanks will be electrolyzed to oxygen and hydrogen by solar cells and transmitted to the reversible cells to give energy and water again. The water will be transmitted to the life support to be processed for oxygen supply. The urine from astronauts will be processed to be used in the shower, and the wastewater will be transmitted to life support to be reused again. The air produced by astronauts will be processed for CO2 removal, then passed to the humidity control to return back for breathing or condensation to be used again. The small gaps in the tensile fabric floors will allow smooth airflow for the supply and return of air. By combining all of that, we have what is called a life support system. SpaceX Starship rocket is going to be our vehicle to the moon. The Starship will occupy our habitat, the service module, and 4 astronauts. The astronauts are supposed to stay in the emergency module till the rocket reaches the lunar orbit and docks with the ISS. At that moment, 1 astronaut will stay in the service module, the rest will move to the habitat to land separately. The journey starts when Starship launches from Kennedy Space Center in Florida, United States. The rocket reaches the low Earth orbit and makes its cycle till it escapes from Earth orbit and the spacecraft separates. The spacecraft takes its journey in space heading to the moon, till it reaches the lunar orbit and starts to do maneuverings till it connects with the International Space Station. The Starship releases the habitat and emergency module separately. After the mission ends, or in case of any emergency, the astronauts take the service module and escape from the moon till they reach the ISS and connect with the Starship again. Or they return back with the module to Earth. When we are able to build small settlements and deeply explore the moon, we could move to the 3rd phase to build colonies and control moon resources. But moving to the 3rd phase would mean that we need to stay for longer periods, and consecutively means we will need more protection in a closed sustainable system between water, waste, and energy. As Eskimos build their colonies in the harsh circumstances by using ice blocks to build igloos. With the same concept, we could use the lunar regolith to make our blocks and build an extra outer protection for our colonies. And for a closed sustainable system, we may be able to extract water from the ice deposits in South Pole, and from the power coming from solar panels, we can generate energy and electrolyze water to form oxygen and hydrogen to be used in reversible fuel cells to produce energy, heat, and water. The water produced could be used for food production, or it could be mixed with wastes and regolith to create regolith blocks to build colonies. And we may be able to use energy from cells to extract water from ice deposits again.